Welcome to chemistry tutorials with Cabbage. Today I'm talking about different reaction types. I'd like to show you how to do the single replacement reactions, also called single displacement. In this one, this is a single replacement. Reaction. The basic form, it could have two different forms. One of them could be where we have something like this, and we end up with the A displacing the B. So we end up with AC plus B. Alternatively, we may have something displacing something else, and so it might look a little different, but we should recognize both of those. So we might have something like AB plus C. It doesn't have to be in this order, of course, but we end up with, in this example, the C would displace the B, and so we end up with AC plus B. I know that the result looks similar. It's because it's a single replacement, but what it's replacing is a little different. Let's look at one such example. All right, one such example that we might see in a lab is where, let's say we have a reaction where, say about potassium bromide. So we have potassium bromide, and we're going to react it with, say, fluorine gas. We wouldn't do this in the lab. That would be dangerous. But what's going to happen is, in this example, the fluorine, which forms an anion, is going to be negatively charged, and it's going to displace the other negatively charged thing. So bromide here, this is potassium bromide, is Br negative, and this fluorine, as it combines with the metal, forms an ionic compound, and it's going to make potassium fluoride. Potassium is a 1 plus. Bromide as an fluoride as an anion is a 1 minus. So we do our crisscross and we get K1F1. And so we don't write the ones, we just have KF. And then we've displaced the bromine. Now the bromine by itself, it's part of our diatomic element. It's one of those. And so we're going to write it as Br2 in this case. And then afterwards we balance it. I'll work one more example. The other case, so example 2 here, we might have a metal displacing another metal. So for example, if we have, I don't know, like calcium reacting with, let's say, I don't know, strontium hydroxide. So in this case, the calcium, the metal, is a metal is going to displace the strontium, which is also a metal, and it's a cation in this case. I mean, the calcium in an ionic compound with hydroxide is going to form a cation as well. So we end up with CaOH2 and just strontium metal. Strontium is not part of our diatomic element, so it's just strontium, like calcium here. So we're going to balance this. We look at it, we have two hydroxides, one each of the calcium and the strontium, so we're actually pretty good. That's it for single replacement reactions.